In this video, I will deal with a very basic problem of pH belonging to both higher secondary students and chemistry honors students. Now the problem is find the pH of 10-7 normal HCl solution. Now since HCl is a monobasic acid, this problem will also be the answer of another problem, that is find the pH of 10-7 molar solution of HCl. These two problems are equivalent in this case. Now major students I have seen in my life that they follow approach 1. They did not think what is given and what to do. They think HCl is a strong acid, so it will undergo complete dissociation. So 10-7 normal HCl is equal to 10-7 normal H3O plus. In this way it will dissociate HCl plus H2O arrow Cl minus plus H3O plus. So there will be complete dissociation. So we have 10-7 normal H3O plus from 10-7 normal HCl. Now the formula pH equals to minus log H3O plus third bracket equal to, we put this value here, so we get 7. So pH equal to 7. Now what does it imply? At 25 degrees centigrade pH equal to 7 implies neutral solution. So where have the acid gone? Is it vanished? So this is a wrong approach. Be careful while doing problems. Now approach 2. When the concentration of HCl is very low to the extent of 10-7, 10-8, 10-6, 10-9, we must not neglect the contribution from self-ionization of water. So when the concentration of HCl is high, to a good approximation you can ignore the contribution from the self-ionization of water. H2O plus H2O reversible H3O plus plus HOH minus. So water upon self-ionization gives a certain amount of H3O plus, which is 10-7 normal at 25 degrees centigrade. But when the concentration of HCl is very low, when it is comparable to this value, we must not ignore this. So here we have H3O plus total equals to H3O plus, that is coming from the dissociation of HCl and from the self-ionization of water. 10-7 plus 10-7 equals to 2 into 10-7. Now put the formula pH equal to negative of the logarithm of the acid concentration. So putting here we have pH equals to 6.6989. This is acceptable. Since at 25 degrees centigrade this pH indicates that the solution is acidic. Yet it is not correct to that extent. It is acceptable but not exactly accurate. So come to approach 3. Since this HCl gives H plus, it will create a common ion effect in this equilibrium, that is the self-ionization of water. Now due to this common ion effect, the equilibrium will shift to the left and will be re-established. So here we notice 10-7, 10-7 for both H3O plus and OH minus. This is the concentration of the respective ions at equilibrium at 25 degrees centigrade. Now 10-7 normal HCl added externally. So we have the H3O plus concentration 10-7 plus 10-7 and this one 10-7, but the product of these two will not give 10-14, which must be. So according to last Chatelier's principle, the equilibrium will shift to the left by an amount x and equilibrium will be established where Kw will be 10-14 again at 25 degrees centigrade. So we have the H3O plus concentration finally 2 into 10-7 minus x and OH minus concentration 10-7 minus x. Now here we have Kw equals to ionic product of water is to H3O plus third bracket into H minus third bracket. Here we put the values 2 into 10-7 minus x into 10-7 minus x equals to 10-14 at 25 degrees centigrade. So rearranging we get a quadratic equation x square minus 3 into 10-7x plus 10-14 equal to 0. Now we have to solve this. Solving this quadratic equation we get two roots. One is 2.618 into 10 minus 7 and another is 0.382 into 10 minus 7. Now since the concentration of the H3O plus at the final equilibrium is 2 into 10 to the minus 7 minus x, this x must not exceed this value, so this root is neglected. This cannot be the root. This is an unacceptable root, but this root is acceptable since it is less than this value. So we have the final concentration of H3O plus as 2 into 10 to the minus 7 minus x. We put this value 0.382 into 10 to the minus 7. We take 10 to the minus 7 as common, and we have H3O plus third bracket equals to concentration of H3O plus equals to 1.618 into 10 to the minus 7 normal. Now pH equals to minus log H3O plus third bracket, so we have pH equals to 6.791. In the approach 2 we got pH 6.69, and here we have an enhanced pH. This must occur because due to common ion effect there is a shortage of H plus ions compared to approach 2, so pH must increase. This is the correct answer.